Tip, read the Canadian supplement before using it. I can't tell you everything that it says, but I think if you're going to use it and specify these properties, you owe it to yourself to read it, understand it as well as you can, so that even if you're relying on an online calculator to do the calculations for you, you are still understanding the context in which you're operating and what you're doing. It provides you with the simplified methods, conservative values, but keep in mind that it allows the use of Part 4 design in place of the simplified methods. And this can make a big difference on a taller building. The supplement might give you a PG 35 or 40 rating on a building, but a specialist engineer who is going to determine code loads on that building might determine that your design pressure is 32 PSF. So you could be, if you require the product's supply to be engineered and tested to 40 PSF when all you need was 32, you're going to be paying a significant premium for additional reinforcing and over-designed glass and other components that you really don't need to meet the code loads. So given that we have engineers involved on complex buildings, I think it's wise to let them determine the actual design of the system and use performance class and performance grade testing as a way of pre-qualifying acceptable product lines and ensuring that the product lines have been tested to minimum requirements that meet your needs. But it's unrealistic to expect a NAFS test for every configuration that you have on a typical window schedule. You might get 3, 4, 5, 7, of the combinations you've got on your building, but you're never going to see them all pre-tested. And by the letter of the law, by the letter of the code, that's kind of what it implies. But now that you have, since you're using engineers anyway, they can vouch for the structural performance of the products, and your NAFS testing will give you the air tightness, the water tightness, and the overall performance class properties that you want to know about that product. When you're using your Canadian supplement outputs to choose a NAFS performance grade, you are going to end up with, you're going to start with hourly wind pressure and driving rain wind pressure. You're going to end up with something called specified wind load or specified water test pressure. And then how do you select the appropriate NAFS ratings? You can do it using tables B1 and B2 of the supplement, but those are metric only, 2 different tables you're working with. Or you can use tables 1 and 3 in NAFS, again, 2 different tables. Or a table that I've put together which combines all that information in one. So you have a single table with all your available values in it. When I give a presentation, I usually give this out as a handout. Can't do that for you today, but if you wanted to download it or see it online, you can see it there. And it's very convenient to have all the available values in one table rather than having to look at multiple tables to see them as you would have to do in the Canadian supplement or in the NAFS standard. So that's unbouncepages.com/NAFS. So when you've got the specified design load, you have to choose performance grade ratings equal or greater than your specified wind load, and I showed you examples of that in the beginning, so I won't go into that in any more detail. So NAFS and Part 9 buildings, we just have a few minutes left. I'll be done here shortly and we'll have time for questions. The question is, who chooses performance grade and water penetration resistance? We don't have a design professional typically involved. Builders are going to rely on their suppliers. Building officials may request information at plan review stage. I know some building departments are asking people to put on their plans, what's your NAFS performance grades? We'll check them, but we want you to provide them. We want you to know that we'll be checking for them when we do final inspection. They will likely inspect the labels to determine whether in fact the products are appropriately rated for the building. And that's likely if they've already been asking you for that information at the plan review stage. Online calculators will simplify this task, but may give slightly different answers for some reasons. And the reasons have to do is that the QAI calculator uses the formula, and the other calculators use the tables in the supplement. And there are times when, because of rounding differences, the table method will bump you up into a next higher performance category than you really need. So I would say that the QAI calculator is the most accurate, but determining values with the table method is perfectly acceptable. But if you're a window supplier and it makes the difference between PG35 and PG40, just because of a rounding error, that's a big deal. So accuracy helps. Code compliance in Part 9 will be based on review of labels. Building officials are paying a lot more attention to window labels than they ever have before. They are much more aware of these issues now that these code requirements are so explicit, but it varies. In some places, they're very clear. Mission is open terrain. This is what we want to see. We're going to be looking at your labels. In other places, they're less, perhaps less vigilant. But one thing that the building officials have been told, and you need to know, is that the label information has to be based on NAFS testing. Whatever rating you put on that label, there should be a test report for that same product at that size or larger than that size to verify that rating. And because NAFS testing is costly, we've found that there are people who are trying to fudge things like that. So, you know, if in doubt, there should always be a test report, and you should be able to challenge anyone that has labeled a product. I want to see the test report for that product, the complete report with all the drawings, and then you should be able to recognize whether or not it resembles the product in question or not. So that's the regime under Part 9. At some level, there's going to be building official oversight. It's going to be based on review of labels. Behind labels, there should be NAFS tests. NAFS in complex buildings, well, Part 5 implies the design team needs to determine the performance grade and water test pressure. Optionally, they may determine the performance class. You can use the supplement or your consultants. In terms of whether the fenestration complies with code, Part 5 is very clear. It's you determine through testing. Products, windows and doors shall conform to these grades when tested in accordance with the harmonized standard. That sounds great. But if you have a window schedule with 17 different configurations of windows and transoms and mullions and whatnot, technically to comply, you'd have to have a test report for every one of those configurations. And that's not always going to be possible. People are not going to have that much pre-testing done. And fortunately, because we get engineers involved in these buildings, we can be less vigilant about the NAFS test report for the structural performance, because the engineering review will actually be more comprehensive than a NAFS test, and will address the real conditions on your building, the real anchoring conditions, the real substrates, guard loads, wind loads, seismic movement, all kinds of things that are not captured in a NAFS test. So we're getting a very high level of review through letters of assurance that I think would not require us to literally require every configuration to have a NAFS test report. Will you be satisfied with labels on the product? Or perhaps you don't want to see labels on the product, especially if it's a large building. Be a lot of labels to remove, and who's going to look at them anyway? What some manufacturers are doing is using their shop drawings as the label and providing all the NAFS performance information on the cover sheet of the shop drawing package. And that seems to me a very practical way of handling it for large buildings, is that you can determine in your specs, even on your window schedule, well, we want to see NAFS test reporting for these configurations perhaps, or just for the standard typical configurations. It's up to you. But that information could be provided on the engineered shop drawings, and you now have a package that gives you both your NAFS data as well as your design drawings. But, as again, you should know that there should be NAFS test reports available, and you can ask to scrutinize those reports as part of the submittal package to satisfy yourself that, in fact, these products have been tested. But, again, will you be able to capture all the configurations on your project? Maybe, maybe not. NAFS testing only rates the wind load resistance of the window, and NAFS testing doesn't tell you how you should anchor that window. So the window can be anchored in a very unrealistic way for a NAFS test. So you might get a really nice test report with a PG40 rating on a product, but it might be installed with shims on all four sides and screwed tightly to the frame, not a realistic real-world scenario. And that's something that the engineering input that you would get from the fenestration engineer reviewing the shop drawings is going to look at the real-world anchoring. You've got to allow gaps, clearances. You've got to allow for seismic movement. That window has to be isolated from the building. So it's going to be anchored very differently than it was in a NAFS test, more than likely. And that's where the engineering input provides you a lot of value, more than the NAFS test itself. So we have this as a mandatory requirement in BC. The engineer provides design, inspection, and letters of assurance that the products, as installed, comply with the code. And this prevents problems we've seen in other provinces where there's often a gap between who's looking after the installation of the windows. You've got a test of a window, you've got a building, somebody installed it and nobody has verified that the installation is appropriate. Happens more than you would think. So I think I've covered all that. So I think it's wise for specifiers to continue to use clauses that require professional engineers to design the systems to the building code loads. I think we should continue doing that and not just rely on NAFS testing to qualify the structural performance of products. Use the NAFS performance class and performance grade to pre-qualify products, but allow the fenestration engineer to determine the project design loads. Consider allowing the fenestration shop drawings to serve as the labels. So that's on the specification end. Finally, products not covered by NAFS. The question was, I've got a multi-use building and I've got the ground floor as all commercial storefronts and entrances, and NAFS doesn't cover those. And you're right, it doesn't cover commercial entrances and storefronts. Basically because there are no performance class requirements for them. NAFS is really keen on defining products by performance class, so there are no minimum test sizes for a storefront window, a storefront door, a curtain wall, and so there aren't any minimum performance requirements. At the end of the day, all you can specify is wind load resistance, air tightness, and water tightness properties. Now, it is legitimate to use the Canadian supplement to determine the level of air tightness. Well, the air tightness is up to you, but the water tightness and structural wind load resistance of products. So you can expect the ground floor commercial products to have the same performance grade properties. But don't expect water penetration resistance from storefront doors or steel doors, because they don't have any, and they won't, just because NAFS came into effect. So commercial storefront doors are actually intended to be used with some shelter from rain, so it's not realistic to expect them to be able to have any degree of water tightness or air tightness. But certainly the structural design of storefront systems can be specified either as a design pressure rating, that again would have to be have an engineer review the design and the anchoring to make sure that a product has the wind load resistance you want, and you could specify water penetration resistance as well, and that would be again done through an ASTM test report, but it's unlikely that you will find the NAFS test report to the actual NAFS standard, because there's all kinds of things NAFS wants to test that are not testable on these products. Yes?
The curtain wall, if it's in a single family residence, does it fall outside of NAFS? Or is it only for commercial?
So, question is, you got a curtain wall in a single family residence, right? So you can specify the water tightness you want. You can specify the design pressure that you want, right? And the question is, what are you going to want to see in the way of compliance? Are you going to want to see engineering or testing? People who are in the curtain wall business don't generally test all kinds of different configurations because every job is different. So they may have some standard testing somewhere for some standard configuration, but it's unlikely that the configuration you've got on that building is a pre-tested one. So basically, for this kind of a product, you're probably going to want to see a test report of that system showing its air tightness and water tightness. And in terms of its structural performance, it's probably more realistic to expect that to be provided by an engineer through engineered shop drawings than it is through a NAFS test report. And you can specify your water tightness, air tightness with respect to ASTM standards, and the manufacturers, the suppliers of those products should have data for them. The qualification I'll make there is that, you know, a lot of these commercial products come from companies like Conair or Commercial Aluminum or Alumicor who make metal systems, and they come to the job site through a glazing contractor. And typically those products aren't tested. The glazing contractor's handiwork, assembly of that project is not tested unless project specifications actually require some kind of lab testing or even better field testing to verify that they're actually assembling it correctly and that you're actually going to get the performance level you want. So I know at RDH we always require those kind of products to be field tested because you never know whether the glazing contractor is going to put it together properly or not. You never know whether it's installed properly or not. So the field testing becomes really important for these commercial products. And the way they come to market, there's no mechanism to have them come to market with predefined NAFS testing because the NAFS testing is done by the manufacturer. And technically, the glazing contractor who assembles it on the job site is the manufacturer, and who's testing his handiwork. So if you're not doing site testing, you really have no idea what you're getting unless you just trust the glazing contractor. So it's a bit challenging to deal with that kind of performance in those type of buildings. There we go. And if you do need structural design to be looked at, it should be done by your specialist engineers, even for Part 9 buildings. So that's it for my presentation. You've got NAFS and the Canadian Supplement in a nutshell, and probably have more questions than answers. If you have any more questions, I'll be glad to take them. I see you've had more than enough. Thank you very much.